Okay, today I thought we'd have a really quick look at equivalent fractions. Now it can be something that's a little bit hard to understand initially, but I thought we'd start with some really basic ones. Now I've got a slightly different setup here today, but we'll see how we go. Now most of us understand that if you have two halves you get a whole thing. That represents what one whole thing would be, right? What is harder to understand is when different fractions can show the same amount. And we've got the set that does this beautifully. So I'll take one of these halves away. So we're left with 1/2. Now there's lots of ways to do it. If I had things chopped into quarters, for example, you can see that if I had 4 of those quarters, that would be the same as one whole thing. Same as if we had 2 of our halves here again, right? Same sort of distance across there. The same is true if I only have half of the set. I have 2 quarters, but it is the same as 1/2. And that's basically equivalent fractions in a nutshell. It's just understanding that sometimes a non-unit fraction like 2 quarters will be the same as a unit fraction like 1/2. Now if we were to carry on this theme, it would work with other ones too. Say if I was talking about eighths, I would need 8 of these blue tiles, I think there's enough here, to make one whole. You can see that they will line up there. But if I only had 4 of those eighths, 4/8, it would be the same as 1/2. And this carries on and on. Now sometimes they don't match. I can't do it with fifths, for example, because it's been chopped up in a different way. So I can have 2/5, which is less than 1/2, or 3/5, which is more than 1/2. So I can't do it with fifths, but I could probably do it with tenths because it's an even number. So if I had 5 of those, you would say 5/10 is the same as 1/2. If I wanted one whole, I would need 10/10. Now, what if the number that we start with isn't a half? Well, that happens all the time, so we'll just put these aside here. What if we started with 1/3? Got a third there. So same as we did with our halves, we would need 3 of those pieces to make a whole, but we're only talking about 1 of those pieces at the moment. So we've got 1/3. Now, what could equivalent fractions be? Say I had something chopped up into sixths. Hopefully that all fits still on the screen. So I've got 6 there. And what other ones might work? Say I had some 12ths. You can see that I need an awful lot of those. Hopefully there's enough left. It's one of those school sets where some of the pieces go missing. I think we might make it. Good, look at that, beautiful. Okay, so that's the whole set. Now, what is the same as 1/3? Well, it's very easy to see. If I measure these two up here, right up next to it, you can see 2/6 is the same as an equivalent fraction to 1/3. Now, you've probably already guessed where it's going with the 12ths. If I move 4 of those up there like that, from my whole set of 12 12ths, you can see also that 4/12 is the same as 2/6 is the same as 1/3. Now the reason we learn how to do this is so that we can simplify fractions in the end, because we don't always want to be dealing with awkward numbers like 4/12. We can say it's the same as 1/3. Can you have equivalent fractions that don't start as a unit fraction? Well, absolutely you can. This is a really good example. Say I've got these 2/5 here. In fact, the fraction would look exactly that as if I wrote it. It would be 2/5. An equivalent fraction, as you can see, these 4 here will line up with it perfectly. 4/10 is the same as 1/5. Now, it's the kind of question that comes up in maths tests all the time. They say, what is the simplest fraction for something like 4/10? You would say, if I line them up next to each other like that, it would be the same as 2/5, which is a simpler way of saying 4/10. And I could keep going. If I had 3/5, I'd just add another 2/10. The relationships between 5 and 10 is that 10 is twice 5, so that makes sense. So you can say 3/5 is the same as 6/10. Now, this sort of thing comes in very useful when you're dealing with percentages. If this was a percentage, it would be 60%, 60 with a percent sign. I can't remember if you've seen that or not. This 6, which then you can simplify into 6/10, and then you can simplify that again into 3/5. So it's the sort of thing that happens in maths all of the time.